Right. Good morning. Let's see here. I'm just reading about looking at state machine APIs from other languages, where I'm currently looking at C sharp, because that's kind of closer to the way you write. Like the challenge with JavaScript is that there's no consistent way of writing code. You can write the code anyhow, any way you want. So you can go like C sharp style, only use classes, mutable, and all this stuff, or you can go like F sharp style, like only functions, immutable, and you have the same with other languages. Hi, Eric. And yeah, it's really challenging. And then you have everything in between. So when you create an API for JavaScript, it's really difficult to kind of find a good surface that makes sense to everyone, because everybody has a different way of writing code in JavaScript just because you can, which is like good and bad. It's good that we have diversity in how we express code, but at the same time, it's much more difficult to deal with all this stuff. Oh, what happened now? Did I add something now to the stream? Oh, anyways. Yeah, so I was looking at this C sharp thing. It's really interesting because they separate the machine from the state. So you pass in the state instance to the machine every time. So you kind of, what could we compare that to? I'm not sure. Anyways, you pass the instance of the state into the machine, and then the machine operates on that state, which is interesting. But you kind of imperatively express the different states and stuff. Where was that? Creating a state machine. I guess quick start was a good one. So you kind of say, so you use a class and you extend like a state machine where you pass in like the type of state this machine operates on. And then you just define these properties, but you don't give them any value, because it's supposed to... so the state machine, the way I understand is that it actually deals with these properties and gives them like its setter and getter. I think I remember this from playing around with C sharp. Anyways, so, and then you kind of in the relationship statement. Yeah, so this is like how you express a constructor in C sharp. It has the same name as a class, which means it's a constructor. And then you kind of just say, you don't point to this in C sharp, you just call it. So initially it comes from automatonous state machine, where you have this like fluent API, I guess they call it, or chaining API, which is like, it reads pretty good. Yeah. But again, like in JavaScript, this is such a good example, because you don't really have a declarative API when you do object-oriented programming like this. That just like in C sharp, and even what was it? Yeah, I guess it's C sharp. You don't really have this concept. Oh, and like in Dart, you don't really have this concept of an object, just a basic object. Everything is like a class instance. So you don't have a way to like effectively describe things declaratively like you can do in JavaScript. Like I'm no expert in languages. I'm just speaking from experience and how I interpret things. But yeah, so that's basically why you see more like fluent or chaining APIs in these kinds of languages, where we kind of frowned upon them in, like, some developers frowned upon them in JavaScript, but that's because they are more like functional developers or programmers, I guess. But anyways, it gives a lot of power because you can do all kinds of crazy stuff here. But yeah, I just wanted to look at this for some inspiration because we have to conclude on our state machine approach. And I've been diving into my little side project this weekend. Super excited to show. I think I can show it by the end of the week. But yeah, because this stuff is still blocking the Overmind release, so I really want to conclude on this. And what we kind of talked about last time, where I was kind of, is this the way we want to do it, is related to, so for example, I guess this is a good example. So here we have this base state called current selection, which means that there are two ways to change state of a machine. You have, so let's say, yeah, we're on the add backlog. Let's play around with the auth thing. So auth, or the root state, is a state machine. And we are able to like transition that thing into something else. So let's say foo. And during that transition, we are able to set the required state for that transition, which is a really good thing to do with this kind of API, because we really want to ensure that when you do actually transition into this state, we have the state that we promised you. If we didn't do that, if we were to like give a callback here, which we can do, and then do like current state or something, then you would have to like add a whatever current state be, and you couldn't ensure that you actually did all these state changes before the transition was done. So you might we might have required A and B, but you only set A, which means that we haven't really given you this guarantee that whenever you transition into foo, you will always have A and B. So that's why this is a good thing. Yes, but then we have this base state, and it doesn't really matter what transition state you're in. We just want you to be able to change something. Let's say current selection. We want you to be able to do this or like in multiple states. Or like, well, it's a base state, so you can change it in any state. And it's more up to us, like when do we actually want to add it, which is what we're doing here. We're just checking, like we can add it at in any state, but we're manually checking if it's in one of these states, we should change it. And then you could say like, isn't this really the job of the machine definition? So when we define a state machine, we say this kind of thing. So we say, let's say we are in valid, and then we say, we can go to error or invalid, for example. And then blah, blah, blah. And then we have like error, and that can move into valid or whatever, doesn't matter. I guess invalid as well. And so on. So the question is like, changing this base state, should this actually also be a transition? So you would do something like state transition, like set selection or something. And then you would say current selection. Like that makes a lot of sense, right? But the problem is we don't want to stay in this transition. We just want to like set it. So the good thing about doing this is that we could rather we didn't have to make all these checks. We could just say, okay, set selection is a new one. And you should be able to do that. Oops, sorry. It's a new one. And you should be able to do that in this state and this state. So we didn't have to make all these checks. We could just transition to it. And then this piece of definition would take care of actually running that transition. The problem though, we don't want to stay in this transition state, right? We want to move back to, depending on the value here, we want to move back into valid, for example. Maybe current selection wasn't, let's use description instead. That's much easier to understand. Set description, like that. So this is a much better example. So we want to set that description, and I think we have some logic. Well, here's the date. It doesn't matter, so we have some logic checking, like, should we be allowed to set this base description now? So we're checking the states manually. But here we're able to just set it, which is super great. But as I said, then we have to define it up here, which is also super great. But now we have to express, okay, whenever you run this transition, flip right back into something else. So for example, we wanted to go into valid state if you have a description, and we want to go into invalid state if you don't have a description. So like, how would we express that? Should it be like a function where you kind of get the new state, and then based on that new state, you kind of return, for example, so new, let's say, description. If we have a description, we move to valid or we move to invalid. That would be one way of dealing with it, for example. And now we could like safely just run this transition, and then it will move into the correct thing. And we would also always set the state, which is what we want. Like, we want to set the state. If it's a valid transition, we will set the state, but then we'll check it to figure out what do we want to flip over to. Yeah, this actually makes a lot of sense in my mind. But we have a problem. And the problem is, what about like, if you don't just have a string? So this is a description. So what if we now move to state transition add to do, for example? Like, what would that mean? And when we add a to do, we want to, like, ideally we just want to pass in the to do, and then you rather under the hood you actually add it. Or we would have to like say to do's, and then we would have to grab the existing to do's and like concat a new to do. So you would always like operate on the list here, which is kind of what we want to get away from, using like a plain imperative API in JavaScript. We don't want this reducer kind of expression of things. Yeah, so the problem is that, but we have to do that because this argument represents state merging, right? So if we were to just pass a to do here, that would just add a to do to your state. It doesn't actually update the to do state. So like, how would you, so you're kind of forced to either do this kind of thing where you have to express like the actual change, and then you would have like in your state machine, you would have like add to do as, and okay, so the thing is, there are two downsides to doing, like, how should I explain it? I like this thing that you have a transition state where you give it a payload, and if it's a valid transition, then it sets it. I really like that. The problem is that it has a cost, and the cost is we have to introduce an additional API, which looks something like this, to be able to express immediate transitions or whatever it's called. And you're forced to changing your state in an immutable way, even though you don't really do that. Those are the problems. That is the problems. That's the probs. So either that, or you could go with an API that said, okay, add to do, and then you would get the state for that thing, and then you would say just push to do, for example. So we can't ensure what you're doing in here. The only thing we can do is that we can give you the state. We can give you the state and allow you to make a state change, but we can't ensure what you're doing there. That might be okay. Maybe that's okay. So you will kind of do, if you wanted to like set a description, you could use an object like this, and then you could use a callback instead if you needed to do something like pushing to a list, right? Because what this, okay, so let's imagine we have this API now. So what would we do here, for example? We would say, we still have this kind of stuff, which we really need to ensure that we're in the right state. So we I feel like we've solved that thing. Like you can argue, like, is this a good way to express it and stuff? But it has all the requirements of dealing with typing and all that stuff. So that's a good thing. So the way we would do this is that we would transition into, for example, set selection, or selection, something like selection. And then we would do selection, or current selection, sorry, is selection. So it would just be that line. We could even like put it right behind here if we wanted. No, we can do that, I think. Oh, this is interesting. Yeah, oh, sorry. We have to actually check if it's, did I comment this out? So we kind of have to do if, and then we could do it. Right. Like, yeah. Like that. So that's nicer. And we would then express in our, let's see, add backlog item. We would express here, we would have like set, oh, what do I call it? Selection. And it would look something like this, where we would just say, when can it, what's this selection again? Is it's if you're on a date or a week or nothing? Yeah, so the thing is, we don't know what the current state is. So you would kind of have to get the state and like current state, where current state is like invalid, valid, or adding. So we would kind of do this. We would just move back to the state we were in, right? So that could be the API of that. And then we would say, okay, when we're in a valid state, we can move to selection. When we're in an invalid state, we can move to selection. If we have an error, we can also move to selection, and it just moves back to error. But when we're adding, we're not allowed to change the selection. So this, I think this makes a lot of sense. Yeah, and then we would write that like that, and then do we have something else? Yeah, so let's check this one. This is interesting. This is where I actually changed the description. So we want to, yeah, let's see, how would this look? So basically, we would, yeah, so this one is very interesting, because we would just say if app state, we would say app state transition description. And then we would just pass the description like that. And we wouldn't actually have any of this logic here, right? Because what we would rather do is when we add this description, we would say state. So if, well, let's grab the description. So if we have a description, we will go to valid, or we will go to invalid. Right, we would express it here instead, which I find super fascinating. And it kind of, it's this decoupling of the machine and the state. The machine, just kind of like what we looked at with automaton, autonomous is you're separating the state from the machine itself. So the machine dictates how it will operate related to the state. And then when you create the machine, that is when you actually provide the actual state value. So we have kind of already moved towards the same thing, which I find interesting. But yeah, this also allows you to do guarding. So for example, if you are allowed to move into a certain state, like transition state, so this is like transition state. So if you're allowed to move into a certain transition state, we can check the state here, and then we can check the state here, and then we can move you to some other state or something. Like we can do stuff. Yes. I think this makes a lot of sense. Because then so the whole conclusion here, like what we achieve here is that whenever, like we can move back into strict mode for overmind, so you're not allowed to do any mutations if you only want to work on state machines. And the only way to make a state change is to run a transition on a state machine. That's the only way to make a state change. And that's a very pure, simple idea. It is. Yes. It resonates with me. Yes, it does. Now, the question is, should we implement this? And I guess I feel a little bit excited to try this out. So yes, we will try to implement this and do another refactor. It's kind of interesting. I was kind of worried. I thought about this over the weekend, like from time to time, like, will anything pop up like during the stream on Monday? Because I was kind of stuck, but it's kind of funny how the subconscious works. Yeah, or maybe this was just pure luck that we kind of tried to go into this. Anyways, so how should we do this? I guess what we would need to change here. So annoying, I have to reintroduce strict mode. Yeah, I guess I can look at the commit. Anyways, but we don't have to introduce strict mode first. We can first introduce this limitation of changing state of a state machine into a transition. And then, yes. Yeah, this is going to be nice. And then, yeah, so let's just do that. Yeah, let's do it. Okay, I'm not sure if I actually have time for this, but let's at least start. Where are we? This is Codesandbox stuff. Codesandbox stuff. Overmind, there you are. All right, so what do we have to do first? Components, overmind, source, state machine. Okay, so we have a transition, we have our states, which we still want to have there. What we've actually changed is this, we have a callback suddenly on this argument. Where do we have this argument? Transitions, machine transitions. This is new. Okay, so this can either be an array of states, or it can be a function. If you remember, we looked at, it's this thing. So it's a function where the first argument is the state related to the machine in this specific state here. Yes. And then the second argument is the current state. So this is kind of tricky. Like, we don't know. I wonder. We might be able to type that, but it won't have that typing initially. So based on this state, we would actually know what other states might be here. So if we had, like, if error didn't have set description, we would be able to say that the only state that could be here is like valid, for example. But yeah, I'm not going to type that. What we are going to type is state, which would be yeah, I guess that's state. It is whatever state is there. But what I do wonder is, yeah, because we also need a base state here. Okay, but we can add this. Base state extends iState, is it? Oh, we have to pass that all over. No, yeah, base. Here we have it. Base. I might, yeah, okay, let's try this. Base. Do is the, yeah, we have base here as well. Base. Cool. Okay, so it can be this. And oh. No, wait. Now, no. I forgot. Like we don't have a specific state here. We just have states. And well, it depends on how we want to do it. No, I think we have to do it like this. Oh, shit. Yeah, this is a tricky one, because here, so the description is like base state here. But what if we wanted to like, what if we actually wanted to look into description? As you know, like now we have like all these things are part of the state, but now they're like null. So when we move into, okay, I think we need these as different arguments. So you would have like the actual state, and then you would have the base state, right? Which is the base state. And then you would have transition state, which could be key of states. And then you have to return key of states. Yes, I think that needs to be the signature, because now we kind of ensure, since you're actually moving into that state, we know that you have that state available. So if we would give like the root state, it would be, well, this is tricky because the base state is on the root state. This base state is a little bit tricky. How should we deal with that? Well, I guess we can, yeah, we can still pass, well, it doesn't matter. We can still pass this in. That's perfectly okay. Oh, you know what's interesting here? No, sorry, nothing. Yeah, well, I guess what's interesting here is if we were to pass in, so you transition into description, and what you basically get here is the payload. So this is like the payload to transition. This would be the machine itself, the state of the machine. Yeah. And then you would have the current transition. Because then you basically, you don't check the existing state here. You check the payload of the transition, right? But you can also check the current state of the machine, which you have no idea, like what's the current state of the machine. Well, you do get current transition, but in terms of typing, you have no idea what's happening here. Yes. Okay, cool. Let's try that. So this is payload, and the payload is is whatever is defined on the type of the state. Sorry if you haven't seen this code before, it might be a little bit confusing, but and this would now be the machine, but it's not like, yeah, so this is the thing, like in this second argument here, you're not supposed to run anything. So I guess we can just we could type it as base. Well, not really base, but it needs to be like base state and states actually. State and then transition state. I think it needs to be like this, because now the first argument is payload to the transition. Yeah, because that means that if you do not return anything, yeah, that's kind of cool. So if you don't return anything from this, like you return false or like something falsy, it means that it doesn't do anything. It just blocks the transition. Yes, it should be like that. I feel it. I feel it. So this can be key of states, or it can be, I think it should be like explicit about that. Yeah, let's, yeah, one thing I do wonder though, when we go down this path and we introduce this callback, does that mean okay, because I think we need yet another API here, because we also need, so for example, valid. No, I don't think so. Yeah, the reason I'm a little bit confused is that maybe we should have like a true as well. Yeah, so if you give false, okay, so false means do not actually transition, which fits really well with giving the payload here, because it's not been, the state hasn't been merged yet. Okay, so false means don't do the transition at all. True means run the transition, but it will stay in this transition. Or you can give a string, which is one of the other states, which means that, okay, run the transition, merge in the state, but then transition right back into something else. But we still have a problem. We still have a problem. And that problem is the payload doesn't actually merge into, it doesn't merge into the root. It doesn't merge into the base state. It's set under, so add to do will kind of be added to state add to do. Here you will kind of get the to do's. Which is not what I want. It would be interesting if it was possible to... Oh, this is tricky. Okay, so what if... Okay, so this is another way to do it. So basically now, when you create a machine, maybe we should look at the tests. When you so when you create a machine, you give it foo, and then the third argument could be like any base state. And currently that base state is like at the root of the machine, and what's specific to a transition state is behind that transition state. So like state foo. what we could do is we don't merge the base state into the root. So for example, if I had foo bar here, oh, sorry, foo is a bad name. So let's say mip moop, that's my secondary foo bar. So you could say, so now you can say state mip, but we could allow you to do foo mip. Now the question is, what happens if I were to state transition into bar? I would have to give bar details. And what would need to happen here is I would have to this is the tricky thing. I will have to well, I guess no, this is really tricky because we're moving the state object from foo into bar. What I was thinking is like it would keep the base state. Maybe we have to express this differently to adjust to all of this. So the reason we have foo bar like this now, we have state foo and state.bar, is because they can be their state or they can be null, which means we can do state foo to properly do the typing. So now we can say if state bar and we can continue and we have our typing. So in that sense, we kind of have to do it this way to get the typing we want. But this doesn't fit very well with the base state. Unlike the previous one, which was state current equals foo. Right? Then you could just have the base state with the rest of the state, like the foo specific state. But now you're not able to say state current equals bar because it's already foo. So we're kind of fucked on that. So how would we deal with this? How would we deal with base state? We would have to... Yeah, I'm actually very unsure on this. How would we do base state in a type safe way? We would kind of have to make... it's so annoying, this typing issue. If we were only able to get past that, we wouldn't have any issue with this. Yeah, how should we do this? But, yeah, no, this is so annoying because you might have logic that says if state transition foo, then do something, and then you want to go further down, you want to go to bar, and this is impossible to type with TypeScript because now we're saying that the state is foo here, and it's impossible for TypeScript to understand that now I want this state to be bar inside here. Like we concluded on that. So we changed this around to be foo bar so that we can rather check if state foo and if state bar. Is there any way we can get around this? So I got this tip from Etienne that if we did this, we could, like if you're using TypeScript and you are nesting transitions like this, like it's possible to use a magical magical function called like reset. And this would actually do it correctly. So if you were to point to state here, it would actually point to bar state. But you have to call this thing, which is incredibly icky. It's so icky. Okay, so this API deals with base state in a really good way, while this API deals with typing in a better way. So we could say, like, but this isn't solved. Like, I have no idea how to deal with the base state here. And this is kind of no-go either, because we can't introduce that. Like, it's super clever what at the end did, but like as in terms of like an API surface, I don't feel comfortable introducing it. So this is basically a no-go. So how would we deal with base state here? So yeah, so the thing is, like, for these transitions to deal with both base state and the specific foo state, this has to be a combination of foo state and base. It has to be that way. Oh, base. It has to be a combination, because if you're only going to do state changes using a transition, you have to be able to change the specific state for the transition state, and you have to be able to change the base state. That's the way it is. It has to work this way. And if those two are the same thing, then the base state has to live where foo state lives. But if you have like state foo and state bar, then the base state kind of has to live behind both of them. Which it can't, at least not with, like, it just can't live two different places. Then it will be like two different objects. And then we could do something tricky, since like we only have one of these active at any point in time. We could like ensure when you transition into foo, we will kind of we would make like a copy of the current bar, and then we would only remove the bar properties, and then we would set foo with the base state and the additional foo specific state. We could do that. But that's like inefficient. Like, there's no need for us to make like a copy of the base state. So imagine like you had a list of 1,000 items of that's like base state, and then we would have to copy that every time. I don't like that either. I don't like that either. What I don't understand though is how like XState uses this API and this kind of typing, and they get away with it. And I wonder how they do that. Maybe because people don't create that complex machines where you want to do this transition, or maybe because it I don't know. I'm not sure. Or maybe people do get into that, but it's considered like an edge case, and then like with all things we just do some TypeScript trickery to kind of forget about that case. Or Oh yeah, wait, we do have one more API. Maybe we should, okay. So there is one more API here, and that is, yeah, but I don't quite like that either, but that is to like say const foo machine, right? And if it did that transition, you can check. If foo machine, foo machine. That's also a way to deal with the typing. The problem though is that it's not ideal because you have to create a variable every time you transition, and you don't have to do that if you don't use TypeScript. This is only because of TypeScript, but you could then say if you don't use TypeScript, you could do this, because it returns undefined if it doesn't run the transition, and then you can just move on with it. Maybe this is the best way to do it though, because if we do it like this, we will have you will be able to put in the payload, merge any base state if you want to do that. Typically you would only do like this, because you're not doing like a side effect, you're just changing the state of the machine or like transitioning into something new. But if you wanted to do that and run some kind of side effect, you would check if you actually got the machine. Yeah, and sometimes you would even just do this. You would just do this because you want to run some kind of effect related to transitioning into foo. Yeah, this is it. Oh, this is very interesting. Yeah. Because we're not, yeah, okay. So the only place you actually wanted to do something like this, bar state, state.transition, bar, whatever, is when you actually want to do something with the state later. So for example, if I wanted to run an effect, do something, and I would say like bar state, description, something like that. If I actually wanted to access anything on that state machine related to some side effect of transitioning that state machine, that's when I wanted to do the variable thing. And maybe that's perfectly okay. Maybe that's perfectly. So I want to try one thing before we conclude here, and that is we have actions, because this is our most complex action. I want to see how does this look like. How does this actually look like if we do this thing? Okay, so we check if we're in the correct, we're actually transitioning into adding. That's what we want to do, and that's perfectly okay. And then we go and grab the add backlog item machine. We grab the profile. Then we run some effects, blah, 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 blah. And we blah, 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 blah. And then, yeah, we transition to invalid. Here we would be able to add the description. We would empty the description. And yeah, it would look pretty much the same, really. We would just be able to add the description here. That would be the only change. Because we do not... Oh no, this is not xstate. This is... like xstate is a very purification of the idea of a state machine. Like it only deals with a state machine. But you have other state management libraries like Redux and Overmind, and this is Overmind, where we are exploring how to introduce the idea of a state machine. And since Overmind has a mutable API, it's not like a declarative API. We are exploring how to get the benefits of a state machine in that context, basically. Yes. Because that's what Overmind is about. You have this basic concept of an action where you do straightforward imperative programming, but then you have tools. So you have tools like functional operators, you have state charts, and also state machine. So you kind of choose the right tool for the job. And you have like a very basic, simple, straightforward way to do stuff. So you're not forced to only using state machines, only using operators, and stuff like that. Yeah. So we've been on this journey together, tweaking, going back and forth on this API, because we're actually exploring it, building an app, so that we're kind of certain that we're choosing the right API for this. Yes. But yeah, no matter, I think since we're already used to, in terms of typing, we're already used to creating these variables. I don't think doing this kind of thing hurts. And it's the best middle way. Yeah. Oh, wait. Yeah, wait. I guess there's one more thing. Because now we're actually matching on a lot of state. But maybe that's what actually gets us off the hook here. Because here we're transitioning. Where did we do the matching? Yeah, okay. Yeah, wait, we're not off the hook here. Because introducing, oh god damn it, this is so difficult. Because if we were to introduce this kind of thing, we would move back to not having this typing, but we would have like everything on the root, right? And then we don't have any way to actually check what state we're in. Then we would have to again introduce, so if we wanted to express this thing, we would have to say, let's see. Let's say auth state. Then we will have to say like state.matches authenticated, and that would return the auth state. So I guess that's the problem. God damn it. So the conclusion is this typing is really well supported for doing a matching. It's great for matching in terms of typing, because you can just check the thing. You can just check the machine. Are we in authenticated? You don't have to create these variables where it's undefined if you're not in that state. Because as I mentioned, if we were to do state matches and do the typing of TypeScript that actually changes this state type based on the return type of matches, then we can't do nested matching and transitions. TypeScript doesn't allow that. So we're kind of, with this typing, we get like a really nice matching API. And with this other kind of typing where we do like current, let me show you. But if we do this states 2, if we do this kind of typing, we get a really nice way to deal with transitions, but now we lose the matching. Yeah, because now we have to match like this. We can't do this kind of matching. Well, or can we? Could we do like, maybe we could do that. Since it returns, yeah, I guess we could do that. So matches authenticated. We could do that. But why, Valentin? But why what? introduce state machines in Overmind? Or let's see. State of matches. Okay, let's see how this one looks with the new API. State of matches. Matches authenticated app notification transition. Oh yeah, let me explain. There is this thing. So if you do, where did I put that? Yes, so if you do this kind of typing, the way you do it under the hood is like matches returns. So you have like matches, and then you say this is state machine of, so you get like the new state here, or match state, something like this. And then just for simplicity, you do something like this. Now you say that this is the new state machine of the state you're matching on, basically. So if you were to do machine matches foo, this works perfectly fine. Now machine is typed to foo. But if I now wanted to do machine.transition into bar, and this could be like asynchronously in some callback or in await or something like that. Now machine would be never. Because in TypeScript, if you express this, then the machine will be foo forever. That's the thing. You can't move it into any other typed state because you said it's foo. And we have a couple of sessions where we've been exploring this. And it's basically just a reduction. That's what this type of typing, it's a reduction of the state. So you start out with any state, and then you say this is a specific state, and then suddenly you don't, now that's the only state that is in terms of typing. So when you try to transition to something else, then you get never, which sucks big time, because that would be the best API, I think. So let's see, show. So you could express it like this, state matches authenticated. And now this will, well, sorry, you do this. Because if this actually returns, if this is true, it returns the machine in that state, which allows you to point to whatever is attached to that state, notification transition show. And then we would wait for some time. And then we would basically have to do the same thing again. Let's see. Hide. But here we're getting into, so we could do like auth state here. We have the freedom to do that. So we could still do like auth state and then check if we have auth state blah blah blah, and then we could reuse auth state here. But I think again, yeah, and then in this case, yeah, here we would actually transition into adding yeah, I think, yes, I'm getting comfortable with this. I think it's better. It's definitely better. Add an extra type argument for the parent. You mean in, let's see. I'm not quite sure what you mean by extra type argument for the parent. I do have I would love for you to look at, do I still have that link? I created a TypeScript playground thing that shows the issue in isolation. I could find that because I'm like 30 minutes past streaming time now. I have to get to work. But yeah, based on our experience now, I'm going to reintroduce matches so that we can write our code like this. It also so you can type the transition methods differently. Oh, you mean that transition and matches are basically pointing to two different types? We did explore that as well. But yeah, let me, this is really, I'd love to get more input on this because I did get some input when we went through it before we kind of concluded that it didn't work. But I would love some more input on that. Yeah, we've been through hell together. Me screaming at the screen and TypeScript and yeah. But yeah, that would be great to get some input on that. I'll make sure to give you the link. Maybe I'll write a comment on the video after I'm done here with the link to the thing. Anyways, yeah, so I guess we'll do that. Valentin will dive into our previous issue looking into the this is typing. Try to find a way to make matches and transition work. This is pseudocode, but kind of like this. And then I'll make the changes to matches like this, and at least go back to this kind of typing. We have our base state with our specific transition state so that we can do all our state changes through a specific transition. We will also introduce the typing for the... do we have an example where I wrote down this stuff? Yes. So that we're able to define transition states that are not only just changing the transition state, but it can do so dynamically by checking the payload passed to the transition. It can look at the current state of the machine, and it can also check what's the current transition state. So based on that, it can basically just move back to the current, well, this is kind of weird. So we can say true, which means that it will move into selection. We can say false, which means that it prevents the transition, or we can make it dynamic based on the payload, for example. Payload foo, then you should move into MIP, or you should move into MOP, or maybe false for that matter. Yes. So I'll do that, and then we'll do another. I'll make sure I'll get that done for tomorrow, and then we'll do another iteration. And if Valentin comes up with something, that's a natural addition to this moving down this path, because it's basically related to how we do the checks here, right? So this would be the same. It would basically be the same. Because you would still, yeah, only that matches returns like true or false. That's the difference. Yeah, so actually maybe, at least looking at this, it's actually better that it doesn't return true or false, but because it means you can just chain on whatever you want to do there. But anyways, I would love to see a solution to the this is typing. Yeah. Okay, I'll really have to stop now. Thanks for following along. And let's, yeah, hopefully we'll get, it will feel super nice tomorrow, and then we're done with this so we can ship the next version of Overmind. Cool. Bye for now. Finish.